Just a moment, we'll start the class. Shall I share the screen? I will share the screen with you and we'll start the class. So in the previous lecture, we have seen that the Ackermann steering mechanism is the one which satisfies the perfect steering equation, wherein we know that it is not the Ackermann steering mechanism. This is not the mechanism which is satisfying the condition for the perfect steering. Rather, the modified Ackermann mechanism is used in the vehicle so that at all the times the center of instantaneous rotation of the wheel is going to be coinciding at one particular point. Okay. So this is how the Ackermann mechanism works. Then we were discussing regarding the turning circle radius. Now the turning circle radius is taken with respect to the center of turning circle, which is nothing but the instantaneous center of rotation for the vehicle. It says that the turning radius or turning path of a vehicle is the smallest circular turn that it can make. Okay, the smallest circular turn that it can make. Turning circles are used to evaluate how easily a specific car can make a U-turn or park. The vehicle's turning circle is the radius or a diameter measured by the outer wheel of a vehicle while making a complete turn. See, please understand that he is talking about the outer wheel. That means the outer wheel is the front outer wheel. That means in this case, this will be the outer wheel. Whatever radius you get, that is nothing but turning circle radius. Please note that the value of turning circle radius, which I told you, it ranges from 3.5 meter, the least value, to the upper value has got no limit as such. But for car, it may vary up to 5.5 or 5.4 meters. So for this particular case, it is in figure. It is shown that the turning circle radius comes out to be 5.4. So this is one thing. This you will find that some of the people, they define turning circle radius with respect to the center of the vehicle. So you can say that this is center or with respect to CG of the vehicle. So whatever CG is there, the turning radius related to CG, that is defined by some of the you can say manufacturer. According to SAE standard, it has to be with the center of gravity of the vehicle rather than with with respect to any wheel. But that is the choice which is given to the automotive manufacturer. Okay, so here please write down the derivation of the turning circle radius, because based on this we are going to solve the problem. So this you can get it from the trigonometric relationship. So the bi, this, let us say this point is b, oh sorry, this point is b and this is I. This small distance is neglected, so it is bi is the pivot center point. So bi is given as L by sine theta, or rather I will write it down on a piece of a paper so that we will solve problems as well. Just wait, I will connect the tab. Just a moment. Please wait for 2 minutes. We'll start the tab. So we will write down the expression for the turning circle radius. So I hope all of you are able to see the. Are you able to see the screen?
Yes, sir.
Yeah. So lecture 8. We'll write down the expression for the turning circle radius. For that, I will draw the configuration. So let us say that this is the front wheel. This is your pivot center point. This is another front wheel. Sir, please understand this very carefully because this is what you have to do it for the actual vehicle, because this is the part of the, this is also included in the practical exercise as well. So please write down whatever I am writing. So this is the modified Ackermann mechanism. So let us say that this distance is represented by B, the pivot center distance. This B is pivot center distance. Then this from the center of the tire to, so A is denoted as the wheel track, and L is shown as the wheelbase. Then theta is the angle of turning of inner front wheel. Phi is angle of turning of outer front wheel. Okay, so if you apply the trigonometric rules for the previous you can say case, then we can simply write down the expression for the turning circle radius, which you also can derive. So I will write down the expression. The turning circle radius of outer front wheel. Okay, this is given as, this is L divided by sine of phi plus in bracket a minus b by 2. So this is the expression for the outer front wheel. Then turning circle radius of inner front wheel. So turning circle radius of inner front wheel. So this is this is given by L sine of theta minus of in bracket a minus b by 2. Then turning circle radius of outer rear wheel. Outer rear wheel. This is given by L cot of phi plus a minus of b by 2. Then turning circle radius of inner rear wheel. So this is given as L cot of theta minus a by b divided by 2. So these are the formulae which can be derived for the vehicle from trigonometric consideration. I was having video as to how the turning circle radius of the actual vehicle is determined. So I will try to find out that video and will show you in the next class or in the practical class, so that you will come to know that how the turning circle radius of the vehicle is determined. So is this clear to you that these are the expressions for the turning circle radius? This is basically wheel track and this is your wheelbase. Now please understand that the equation for the perfect steering is, what is the equation for perfect steering? Sir, what is the equation for perfect steering?
Cot theta minus cot phi is equal to c by v.
Cot of phi minus cot of theta is equals to b by L. Is that correct, or it is the other way around?
Sir, it is cot theta minus cot phi is equal to c by v.
Yeah. Okay. Cot phi minus cot of theta is equals to b by L. Okay. Here, C is this pivot center distance. We have taken it as B. Okay. Here it is written cot phi minus cot of theta is equals to b by L. For our configuration, it is going to be b by L. This is B, pivot center distance. This is the pivot center distance. So cot phi minus cot of theta is equal to b by L. So this is the equation for the perfect steering. Now we will solve the problems based on finding out the turning circle radius of the vehicle. So is it fine, sir? आगे बढ़े क्या? किसी को कुछ डिफिकल्टी है क्या? एंड यही इसमें मैं लिख देता हूं, जनरली और generally theta plus phi should be less than equal to 70 degree. That is basically the thumb rule. Thumb rule का मतलब ये नहीं है कि ये कंडीशन हर बार सेटिस्फाई होगी. So this is basically going to be the starting point for designing of the system of the vehicle. So shall we now ट्राई टू सॉल्व द प्रॉब्लम। सर किसी को कुछ डिफिकल्टी है क्या? तो इस पे एक प्रॉब्लम सॉल्व करते सर हम लोग, करें क्या सर? ओके यस सर, ये अभी का है या कब का है? ठीक है, 9:16। चलो ठीक है, तो अभी प्रॉब्लम लिखो। अ मोटर कार, a motor car has a wheelbase of has a wheelbase of 2.743 meters and pivot center of 1.065 meters. The front and rear wheel track, the front and rear wheel track is 1.217 meters. Calculate the correct angle of log. Calculate the correct angle of log and turning circle radius of outer front and inner rear wheel. Inner rear wheels when the angle of inside log, when the angle of inside log is 40 degrees. सर क्या क्या दिया है सर उसने, आप प्रॉब्लम पढ़िएगा। What he is saying, a motor car has a wheelbase of 2.743 meters, okay, and pivot center is given as 1.065 meters, okay. The front and rear wheel track is 1.217 meter. Calculate the correct angle of log. What do you mean by angle of log? Angle of log. He is not asking you of which wheel, whether the inner front wheel or the outer front wheel. And further he has given and turning circle radius of the outer front wheel and inner rear wheel when the angle of inside log, when the angle of inside log is 40 degree. That means this, whether he has given theta or phi, थीटा दिया है या फाई दिया है सर, हमको सर प्लीज गेस what he has given you, whether it is theta or phi. He is saying that inside, so he has given us theta. So theta is basically he has given as 40 degree and 40 degree, and he is asking us to find out the phi. So please try to get the answer for this particular problem. I will just change the page. सर इसका कृपा करके सर आंसर फाइंड आउट करिएगा। आई एम शिफ्टिंग टू न्यू पेज। तो सर हम लोग अभी पहले फिगर निकाल लेते। तो ये है सर व्हील बेस आपका, सॉरी ये आपका व्हीकल है, ये पिवोट सेंटर डिस्टेंस उसने दिया है 1.065 मीटर्स। Then sir, he has given us, has he given wheel track? व्हील बेस दिया हुआ है. दिस व्हील बेस इज गिवन एज 2.743 meters और व्हील ट्रैक जो दिया है आपको सभी डायमेंशन दी है 1.217 मीटर वाली डायमेंशन दिया है. सो फॉर परफेक्ट ऑब्लिक correct steering, we know that cot of phi minus cot of theta is equals to b by l. So cot of phi minus cot of 40 degrees is equals to, what is b? B is given as 1.065 divided by L is given as 2.743. So from here get the value of, you can say, phi. सर phi कितना आता बताइएगा. phi comes out to be सर 25.82 आता है या 32.4 डिग्रीज आता है. 32.33. okay, 32.33 degrees, that is the value of the phi. According to my calculation also it comes out to be 32.4. Now turning circle radius of outer front wheel. So TCR of outer front wheel. So what is the expression for this? This comes out to be L divided by sine of phi plus 1.217 minus 1.065 divided by 2. आपको ये L मालूम है, phi मालूम है. So please let me know what is the value. This is 2.743. Then sine of 32.33 प्लस ये आएगा 0.152 डिवाइडेड बाय 2. सो सर इसका वैल्यू आप बताइए कितना आता है. तो सर इसका वैल्यू कैलकुलेट करके बताइए. देन टर्निंग सर्कल रेडियस ऑफ इनर रियर व्हील, इनर रियर व्हील. सो इनर रियर बोला तो उसने ये L cot of theta minus of your 1.217 minus 1.065 divided by 2. तो आपको ये L मालूम है, L दिया है 2.743 cot of 40 माइनस ऑफ ये हो गया आपका 0.152 डिवाइडेड बाय. हाँ सर इसका वैल्यू बताइएगा कितना था. पहले का आता है 5.20 मीटर और सर दूसरे का कितना आता है. दूसरे का कैलकुलेट कीजिएगा. हाँ 3.19. सो 3.19 मीटर. So these are some of the simple problems which are there for, you can say, the calculation of the turning circle radius. So similar kinds of actually this is the demonstration to you people that how do you calculate the turning circle radius, but you have to do it for the actual vehicle in the practical class. So आपको व्हील बेस की इसलिए स्पेसिफिकेशन चाहिए और इसलिए आपको पिवोट सेंटर डिस्टेंस देखना है कि स्टीयरिंग को आपको गाड़ी में बैठ के चला के देखना है कि नीचे कौन सा ये जो है ये मूव होता है. ओके आदित्य, व्हाई यू जॉइंड लेट? one more thing, what is your expectation that when the vehicle is parked in the parking lot and if I ask you to move the steering, will you able to move it so easily? सर आप इजीली मूव कर सकते हो क्या सर स्टेयरिंग? नो. What may be the reason? Okay, you think, and I will tell you the reason. Static friction. Okay, ठीक है. तो सर ये पावर स्टेयरिंग टर्न ऑफ. ओके, चलो फिर अभी इसके बाद अपन पावर स्टेयरिंग की बात करते. तो पहले ये तो बात कर लेते कि एक प्रॉब्लम सॉल्व कर लेते, फिर आपके ये क्वेश्चन का मैं आंसर दूंगा. Let me see. For power steering, static friction is more than kinetic friction. Okay sir. Then steering lock. ओके, चलो ठीक है. आप इसका आंसर देखते कि क्या है. ओके, नाउ बिफोर दैट आई विल गिव यू वन प्रॉब्लम फॉर यू टू सॉल्व. राइट डाउन अ प्रॉब्लम. अ कार हैविंग अ व्हील बेस. A car having a wheelbase of 244 centimeter and pivot center of 112 centimeter has a track of 122 centimeter between centers of tire tread, between centers of tire tread. If the angle of lock is 30 degree and width of tire is 11.4 centimeter, determine the minimum radius of outer turning circle. The minimum radius of outer turning सर्कल. सो ये सर अभी आपको डिसाइड करना है कि उसने यूजुअली अभी क्या दिया है. वो तो कुछ भी नहीं बोलता. इफ द एंगल ऑफ लॉक इज 30 डिग्री एंड, तो सर अभी हम लोग लॉजिक लगाते हैं कि इसको क्या लेना, इनर लेना, आउटर लेना, क्या लेना सर. ये सर एग्जैगरेटेड फिगर है. दिस इज नॉट टू दी प्रोपोर्शन, दिस इज नॉट टू दी स्केल. जस्ट फॉर द सेक ऑफ अंडरस्टैंडिंग कि उसने क्या क्या दिया है और अपने को क्या क्या निकालना है. सर ये अपना हो गया पिवोट सेंटर डिस्टेंस. ये अपने को चाहिए सर एक्सप्रेशन में, बिकॉज cot of phi minus cot of theta is equals to b by l. तो ये l तो उसने दिया है, ये दिया है आपको 2.44 मीटर दिया हुआ है, 244 सेंटीमीटर्स का. ये a car is having a wheelbase and a pivot center of 112 दिया हुआ है. ये सर उसने 112 दे दिया है आपको. ये सेंटीमीटर में है, ये मीटर में. ओके, एंड हैज अ ट्रैक ऑफ, ये उसने ट्रैक भी दे दिया आपको. अभी सर अपने को कुछ जरूरत है क्या? 122 सेंटीमीटर. तो ये आपका हो गया ए. ये आपका हो गया B और ये आपका हो गया L। तो सर ये तीनों चीजें तो अपने को जो रिक्वायर्ड है एक्सप्रेशन में वो तो मिल गई है। नाउ द क्वेश्चन कम्स वेदर अभी उसने व्हाट ही हैज सेड, हाँ स्टीयरिंग नॉब, ओके चलो ये पुराना है। तो द क्वेश्चन कम्स वेदर this has to be taken as the theta or phi. So in your opinion what it should be, whether it is theta or whether it is phi? सर अभी इसको क्या लेंगे सर, हम लोग थीटा लेंगे या फाई लेंगे? सर इसको हम थीटा लेंगे। अच्छा ठीक है, और कोई बोलते हैं सर फाई लेंगे, जैसे प्रद्युमन ने कहा कि इट हैज टू बी थीटा, प्रज्वल इज सेइंग दैट इट हैज टू बी फाई, सो व्हाट इट शुड बी? सर इसको एक जस्ट एक लॉजिक लगाते, दोनों का भी बराबर हो सकता है, आई एम नॉट सेइंग, यू कैन से दैट जनरली theta is greater than phi. You agree to this or not? Yash, do you agree with this? Shravya? Okay. So now we also know that theta plus phi is almost equal to 70 degree. This is thumb rule, but may not be true in all the cases. Please note that once again I am repeating that this is a thumb rule, may not be true in all cases. So now if you consider this theta, if you consider this as theta, then it will violate this particular assumption. Okay, then according to this rule, if first case, if let your theta is equal to whatever he has given 30 degree, then approximately phi comes out to be 40 degree, which contradicts the rule, that is theta is greater than phi. Okay, so in second case, if phi is 30 degree, then phi plus theta is equals to 70 degrees. So from this expression, this comes out to be theta as 40 degrees. Okay, so therefore your theta is greater than phi is satisfied in this case. So usually the logic is you take whatever is given, you see the value of the angle and you see this general expression, and based on your logic you choose whether this is theta or phi. Okay, so theta is equals to 40 is basically the logical way, but it can be other way around in the exceptional cases. So please don't take that theta plus phi has to be exactly 70 degree. This is true as far as most of the cars which are running on the road, but in specific vehicle for specific steering system which is designed by the designer, there can be exceptions. Okay, nowadays there are so many steering systems which are coming, how you can park the vehicle, you can slide the vehicle on the left hand side, you can slide the vehicle on the right hand side, and so many things. But for our particular discussion, we are going to consider only normal car, and for that normal car, theta plus phi is usually 70 degrees. In exceptional cases, it may be more than 70 degree, but theta will be always greater than phi. So based on this particular logic, in this particular problem, you take phi as 30. So whatever is given, you say that the phi has to be 30. In bracket also you write down that assume. Okay, though it is given, but please try to say that you assume, and then you can try to solve the problem. So such kind of some vague data problem, they have to be tackled properly. See, please note that in automobile engineering, there is nothing like right and nothing like wrong and nothing like a perfect value. So because these are the iterative process, this is the combination of science, art and technology, then you cannot bind all these three, you can say, streams into one particular formula and use that formula to get that. But all dimensions or all the things which you design or all design dimensions, they have to be based on certain specific, certain engineering logic. Okay, so it cannot be just you felt and you have taken the value. That is not the thing. But you will find that, have you seen any book on the design of the vehicle? You please tell me. Like what you have, you might have read design of the shaft, design of the gear, design of the chain, design of the pulley, design of the you can say some joints, but you won't see the any specific book which is written on the design of the vehicle. It will say that though the title says design of the vehicle, but you won't find any formula. All that particular book will contain only and only correlations, thumb rules, and some formulae which will able to give you certain kind of dimension which you further modify and then take the logical decision. So have you understood this? Then shall we go to the next topic? Okay sir, so आगे चलने का क्या सर? ओके, चलो ठीक है. So I hope you have understood this. Now we will discuss the power steering. So what do you mean by power steering? So please put your answer in the chat box as to what do you understand by power steering. So sir, बताइए sir, power steering. Now power steering is nowadays feature of all the cars. Do you agree? Can you name any of the vehicle wherein the power steering is not fitted? Sir, Maruti 800 Stravya, it comes with the power steering. Tractor, so tractor requires power steering, Utkarsh. Old Maruti, agreed. Yes, you are right. Old Maruti 800 basically. Ambassador, yes. So most of the old vehicles, they were, no, Pradyuman, these buses, they are with power steering. There's no, otherwise the driver will get fed up by just driving 70-80 kilometers, or otherwise he will have to build his muscles so that he can drive the bus. Okay, so please understand that the old vehicle which was last vehicle without power steering is Tata Indigo old that used to come with the power steering sir. सर सिर्फ मारुति जो वैन थी, it was without power steering. Okay, and recently they have also shifted to the power steering because the problem with the ordinary steering system is the driver will get fed up by steering and there will be a lot of fatigue. So I do not know about Tata Indigo old, but as far as the first batch Tata Indigo was there, then it was with the power steering. Then old Thar was also with the power steering because that used to, that is a Thar vehicle is basically it is now it has been launched in domestic market, but when I was working in the Mahindra and Mahindra, the Thar vehicle, very similar model was available where they used to export that model to the Gulf countries, and it used to come with the petrol engine, and that petrol engine was having the problem of the fuel economy. It used to give only 5 to 6 kilometers per liter for the gasoline engine. Okay, and now then they discarded the engine. let me tell you that I was the person who was working on that petrol engine, and that petrol engine was P2150. That's a old Peugeot engine, and then subsequently it has been discarded because the fuel economy was not good, and that is why that vehicle was not launched in the domestic market. Whereas Mahindra used to sell that vehicle to the Gulf countries because there the petrol was not an issue, gasoline was not the issue. Now, whatever Thar vehicle you are seeing, that it's a modification of old Mahindra 4x4 vehicle. Okay, so I have not seen that Thar vehicle actually, the new one. I have seen some tractors that don't have front axle used for sugarcane harvesting. How the steering is done in it. Sir, I am not aware of this, Pranay. You might have seen that on Discovery, or actually also you might have seen, but I have not seen. So I can't comment on that how it can be done. If you can show me the some photograph or something, then probably I could able to make out. But frankly, I have not seen such things. So it's not better on my part to comment on that. Okay. So now power steering. Let us see what is power steering. Most of the people now, your generation, you might not have driven the vehicle fitted without the power steering, but I have driven the vehicle without power steering, and I know the difference between power steering and all. It becomes very troublesome if you want to park the vehicle, specifically if it is without power steering and if it is loaded. Okay, because as such the steering becomes very difficult. So we'll see the need for power steering. So what is the need for the power steering? What it says, with tendency of putting more weight. The क्या हो गया है sir? Engine is mounted on the front of the vehicle. So उसके कारण क्या होता है? You got more amount of weight to be put on the front of the vehicle. एक मिनट, just मुझे highlighter देने. Now what it says, with the tendency for more weight to be put on the front wheel, front steering wheels in the front wheel drive cars, and the utilization of radial ply tires having greater width, large static torques are required. See what is going to happen if you mount the engine at the front. That means you are putting more weight on the front axle. If the normal reaction is more, then your frictional force mu into N, that is basically a static friction, that will be large. So you will not able to steer the vehicle after particular angle. So that is why it says that large static torques are required. Large static torques are required. That means you have to be a bodybuilder. Okay. The driver's expectancy for faster driving and cornering makes power assisted steering desirable. He is saying that it has to be a desirable feature. Means it is basically the luxury added to the vehicle. Without power steering also, can you drive the vehicle? Sir, without power steering आप vehicle drive कर सकते हो क्या? Okay, so that is why he has used the word desirable, and in some cases essential if the driver's ability to handle the vehicle to match its performance. See, power steering plays a very important role when you take the turn, when you are cornering the vehicle at the high speed. The power steering makes you a very comfortable cornering, and it gives a quick response. So what is basically power steering is, power steering reduces the driver's input to something like 25 to 30% of the total work needed to maneuver the vehicle. Please understand that this number is important. It will totally not control the vehicle effort. Okay, that means you cannot have, if the vehicle is fitted with the power steering, don't expect that you don't have to work hard. Even suppose you have to put the effort of 100 joules, let us say 100 joules of energy is required, then out of that 100 joules, 25 to 30% of the total work needed to maneuver the vehicle will be contributed. That means 25 to 30 joules of energy is contributed. Now the question comes, okay, whether it has to be a regular feature, that means it is doing it for all the time or in some particular cases or at some particular case of steering. That is important. So what is your opinion, sir? Sir, my question is whether it has to be there at all times or at one particular instance of time, at a particular case like turning. So when it comes to in action, when the steering wheel is given a direction, okay, that is okay, because the steering is all the way is giving the direction. So when it will come into picture, sir? Sir, suppose now you are a designer and you wanted to fit the power steering. So what is the disadvantage of fitting the power steering? When the steering wheel is given a direction, yeah, that is okay, because then and then only you can turn the vehicle. But at every direction, at every point of view, it will come into picture. It will contribute all the time. When a minimum torque is given, what is minimum torque, sir? Minimum torque of what? Suppose you are a designer, now you have been asked to fit the power steering. Will you make power steering working at all the times? Will work after a certain energy is required to turn. Okay. Okay, I'll answer your question. See, you have given answer to my question that नहीं sir, ये हर बार जब हम लोग व्हीकल ड्राइव करेंगे पावर स्टीयरिंग नहीं चलेगा. एग्री. व्हाई इट शुड नॉट? डिपेंड ऑन द स्पीड. देवांश, आई विल कम टू योर you can say your point of view. It absorb energy. सर absorb energy यानी कौन एनर्जी absorb करता है? सर एक बात सर, थोड़ा सा इंजीनियर बन के सोचिए, ओके, कि आपने पावर स्टीयरिंग सपोज मान लो कंटिन्यूअसली ऑन रखा, तो व्हाट इट इज गोइंग टू हैपन टू द व्हीकल? व्हाट इज गोइंग टू हैपन टू द व्हीकल परफॉर्मेंस? सर फर्स्ट थिंग, मैंने आपको जस्ट एग्जांपल दिया. सर थोड़ा सा लॉजिकली सोचिए कि आपको इसमें सर कि मान लो 100 जूल है, 100 जूल ऑफ एनर्जी आपको स्टीयरिंग को लगती है, ठीक है. 100 जूल में से आप 75 ड्राइवर कंट्रीब्यूट करेगा और 25 जूल जो एनर्जी है ये पावर स्टीयरिंग कंट्रीब्यूट करेगा सर. तो सर ये एनर्जी कहाँ से आएगी सर? 25 जूल वाली एनर्जी कहाँ से आएगी? इसके बारे में कुछ सोचा है क्या सर व्हीकल में? डिक्रीज फ्यूल इकोनॉमी. सौरभ, वेरी करेक्ट. So it will come from the power steering, but parasitic power. Okay, what is sir Anshuman? What is parasitic power? Means what you can say? Sir, आप unmute करके बात भी कर सकते हैं sir. It's a discussion. We should understand the logic. That's it. My intention is we should understand the logic. तो सर ये मोटर तो नहीं है सर, ये सार्थक, ये मोटर जो वर्ड है ये सर आप थोड़ा सा अभी टाइम बीइंग के लिए बाजू रखिए. This will come into picture only when we are discussing the electronic or electrical power steering system. Absorb power from the main power to ease steering. So what is the main source of power? Sir, vehicle में main source of power is engine. Very good. So vehicle में main source of power is engine. Now if you are taking the 25, and this is an example, 25 joules at all the times from the engine, and you are not utilizing it, that means first thing, where that energy should go? That is the first question. Second is, if you are unnecessarily wasting the 25 joules of energy, then you are unnecessarily burning the fuel, because the energy comes from the engine and the engine gets the energy from the burning of the fuel. So you are increasing the emissions of the vehicle. That is one aspect. That means you are polluting the environment. The second is you are reducing the power output of the engine. and third is you are burning more fuel. So if more fuel is burned, the fuel economy is getting hampered. Okay. So first logic is that we will not use power steering at all the times. Is this clear? So we are not going to use power steering at all times. Then when we are going to use the power steering, we are going to use the power steering when the driver's efforts to steer the vehicle exceeds the predetermined value. That means some force, some setting has to be done in the power steering in such a way that if the driver applies the force to a value which is greater than the predetermined value, in that case, to reduce his efforts from that high, from putting the high effort into the steering, it will be contributed by the power steering. Otherwise, at all the times, the power steering will not come into picture. यानी पावर स्टीयरिंग तभी अपने समझ में आएगा, तभी काम करेगा जब ड्राइवर के जो एफर्ट है वो एक प्री डिटरमिन्ड वैल्यू से ज्यादा होंगे. अदरवाइज power steering will not come into the picture. So please keep this thing in mind, that power steering comes into picture only when the predetermined effort of the driver it exceeds. If the driver's effort exceeds the predetermined value. So this is basically the idea for the power steering. That is first thing. The second requirement is, in the event of the failure of the power steering, the normal steering of the vehicle should continue. These are the two things these are the two things for which the power steering is fitted in the vehicle. तो सर बात आपको समझ में आई क्या? पावर स्टीयरिंग क्यों लगाना है और उसका काम क्या है? Yes or no? Okay sir. So now today we will stop here. If you do not have any question, if you have any question, please ask. If you do not have any question, we'll stop here sir. सर आपको कोई सवाल है क्या? पूछिएगा. अगर नहीं है तो then you can leave the meeting. It is over from my side.